All right, this is Algebra 2 411, and we are going to be talking about different strategies that we can employ for solving equations. So to start off, we're going to take a look at this problem here. So this is solving things graphically. So if we have the function here, x plus 3 to the second minus 5, that graphs and gives us this. Great. So if we try and solve this algebraically, with a graph, we're going to be looking at, hey, where does that cross the x-axis? Now, that's not necessarily very easy to do when we have a graph, because it's not going to be nice, whole, pretty numbers. There are going to be some decimals. So even though you can have a program tell you the exact point, most of those programs are going to give you a decimal approximation, not the actual radical or fraction or things like that. So even there, you are still going to be writing it. And that's one of the big downfalls of solving via graphing. But if it does give you nice whole pretty numbers, it works great, right? And one little caveat that we can do here, and this is the kind of new part of this, is we can really solve by graphing, by just graphing both sides of one equation and finding where those intersections are. So the first way that we're going to see that is, this is typically how we would solve, hey, when x plus 3 to the second minus 5 is equal to 0, it's here and here. Now that works because when y is 0 is on our x-axis. But what if I make that y 4, right? Well, y is 4 is right here. So then it's true here and over here. And I can make that more complex than just 4. I can make it some other function, right? And then look at, hey, when is this function equal to that function? So that's the kind of next step which we're going to be looking at. So for the same reason that I can now solve this equation by basically graphing the line y is equal to 4 right across here, and seeing that I cross at -6 and 0, those are my solutions. I can solve more complex things by just graphing whatever's on the left-hand side and whatever's on the right-hand side and looking for the x values of those intersections. So that's the kind of big first thing here. All right, so now let's try and talk about solving this algebraically. So go ahead, pause, and try and solve this equation here, the same one we just did algebraically. You should already know that the answers are -6 and 0, but just verify that algebraically and then come back here. Okay, so let's go ahead and work through that particular problem. So we have x plus 3 squared minus 5 equals 4. So the first trick that we want to kind of go over here is, it's tempting to say, well, I can take this and I can multiply it out because it's a binomial times a binomial, and that will work. But it's going to be a lot easier for us. We could just try and isolate that power. So I'm going to move that 5 over. I got x plus 3 squared equals now 9. Then I can square root both sides and get x plus 3 equals plus or minus 3. And now I have two equations. X plus 3 equals 3. And x plus 3 equals -3. Solving these both out individually, this will give me 0. And this will give me -6, which is like we predicted. So there's my two solutions algebraically. Now that's kind of our first new little trick, is basically trying to isolate those powers and then square rooting as opposed to multiplying it all out and then trying to factor it once I've combined like terms. Even though that will still work, this just gonna save you a little bit of time and effort there. All right, so let's take a look at this next problem. So I'm going to kind of disregard most of what it is saying here just to kind of give us the kind of meat of what is going on. So we're going to just take a look at this equation here. Right? So we have x minus 5 over 4 plus 2 over 5 equals 9 over 10. All right, let me pull up my document camera. All right, so it's like I'm going to sneeze and pause this. Okay, sorry about that. Okay, so looking here, this is ugly because there's all these fractions in it, and I really don't like working with fractions. So one thing that we can do is we can say, well, let's find the common denominator. What's our least common denominator of 4, 5, and 10? Well, it's going to be 20, right? So I'm going to multiply everything by 20 on both sides. Now what this does is it gets rid of all of my fractions all at once. Now there's ways to still do this, but do it a little bit by a little bit. But if you can find that least common denominator, it's just one step as opposed to multiple steps now. So 20 times something over 4, the 20 to 4 is going to reduce to a 5. So this turns into 5 times x minus 5. 20 over 5 is going to turn into a 4. So that's 4 times 2, which is also known as 8, equals 20 over 10 is going to reduce down to just 2. 2 times 9 is 18. And there we go. So now I can just solve out this. This is relatively easy for me to solve out. Move that 8 over. 5 times x minus 5 equals 10. Now we can distribute that 5 through and then solve it out there. But I see that my 5 and my 10, well, my 10 is divisible by 5. I can just divide both sides of my equation by 5 right now and save myself a little bit of hassle. You can still solve it the other way, but if you say, hey, these are divisible, let's just go ahead and divide that off then. And then I can add 5, and x is equal to 7. There we go. Okay, so that's our kind of other trick, is basically taking the denominators, finding a common denominator, and then multiplying it by that. That gets rid of fractions for us. And that's probably one of the most useful tricks out of all of these, because this is very solvable without doing that. But then you're just adding and multiplying with fractions the entire problem, which just makes it take a lot longer, because fractions are not things you're as good at just kind of knowing off the top of your head, whereas nice, pretty whole numbers, you should be pretty darn good about working with those. So with that, here is our homework for 411, and I will talk to you guys next time.